1965. The Canadian Alcan Aluminium Limited and the German VAW Group formed a partnership for the future and founded Aluminium North. At the time, Alu North in Neuss on the Rhine was Europe's largest aluminium rolling plant. A steady increase in turnover in the packaging market, as well as new developments in the automotive industry, led to extensive expansion in the mid-90s. With a construction time of only 3 years and an investment volume of almost 1,000 million marks, a gigantic project was started, at the end of which, from the 575,000 square meters of ground area, more than 268,000 had been roofed over, and a further 162,000 square meters turned into roads and storage areas. State-of-the-art technology, highly economical production routes and efficient equipment were the criteria needed to open up a new dimension in aluminium processing. All the employees, planners, technicians and engineers involved were faced with the challenge of how best to unite existing technology with the new equipment to be built. Today, Alu North stands out as a shining example of the fruits of this effort. Perfected logistics and technology, high product quality and supply flexibility, teamed with high safety levels and low costs. A production capacity aimed at world markets. The remelt was enlarged with 3 melting and casting units to produce 750,000 tons per year. Building a second hot rolling line increased the hot mill capacity to 1.5 million tons. The cold mill bay was expanded by the addition of a 2-stand cold tandem mill. This pushed the production capacity to a total of 950,000 tons. The new plant concept enabled Alu North to set new standards for the production of aluminium, now making it the largest aluminium rolling mill operation in the world. The start of a fascinating production process. Aluminium pigs from all over the world and uncoated processing scrap are melted down in 13 remelt furnaces. These giants, with capacities up to 120 tons per furnace, melt up to 36 tons per hour. Monitored by a sophisticated scrap recording and cast information system. The chips from ingot scalping are melted in induction furnaces with minimal loss and fed into the cast as molten metal. The oxide formed during melting, the dross, is skimmed off the melt surface. At the end of this natural gas-fired process, the molten aluminium is transferred to holding and casting furnaces, from which it's cast into rolling ingots of the specified size. The dimensions of the cast ingots are 60 centimeters thick and up to 2.20 meters wide. To use the capabilities of the new rolling mills to the full, the ingot length was doubled to 9 meters. This results in individual piece weights of 32 tons, which first have to be transported. Modern cranes and hydraulic lifts master this task, partially below ground, on the way from the casting shop to the ingot preparation hall. Here, the ingots are sawn at one or both ends, depending on their end use. A new double-band saw, which replaced the circular saws used previously, has resulted in a considerable reduction in chips and end scrap. To achieve the best possible final product surface quality, the ingots are now scalped on both sides simultaneously. fully automated pusher-type furnace homogenizes the ingots and brings them to the hot rolling temperature. These hot rolling ingots at 540 degrees are transported with uncanny precision at a height of 5 meters to the hot mill roller table. After passing the vertical edging mill, the 4-high reversing breakdown stand of the new wide strip mill rolls them down to a slab of 34mm gauge, using between 13 and 25 passes depending on the type of alloy. The ends are removed in the cropping shears, and the slabs are transported to the 4-stand tandem mill. In only one pass, the gauge can be further reduced down to only 2mm, and that at a rolling speed of 480 meters per minute. The strip is finally trimmed and rewound on the mandrel, producing coils of up to 2.7 meters in diameter. Integrated measurement and control systems, coupled with CVC technology, guarantee consistently high quality through all these processing steps. The inner laps of the finished coils are subsequently spot welded for transport. The hot mill coils, which still have a temperature of about 300 degrees, are now moved by a partly underground transport system to the new high-rack store with 830 places. Here, a new air conditioning ensures a short cooling time. The cold bay has 4 non-reversing 4-high mills and 1 2-stand tandem mill. They're equipped with hydraulic gap setting and automatic gauge control. CVC technology shifts the work roll sideways, permitting a continuously variable roll gap, an important prerequisite for optimum flatness. On these mills, the hot mill coils are cold rolled to gauges of 0.2mm to 4mm in widths of up to 2,100mm. Speeds of up to 1,650 meters per minute are reached. Automation systems and numerous aids guarantee a consistently high quality level at all stages of production. The air exhausted from the mills is cleaned of rolling oil by passing it through an extensive system of scrubbers. These air-pure systems are a worldwide Aluminievый patent and meet the strictest environmental standards. Depending on the alloy and strength required, the coils must be inter-annealed between the cold rolling passes. This is carried out in batch annealing furnaces operating with a nitrogen inert gas atmosphere to prevent any oxidation of the strip surface. The coils are then passed to the finishing bay for trimming to width. For this, together with slitting, there are 8 slitters, as well as additional strip embossing and relubricating equipment. 2 further cut-to-length lines can make sheet out of the coils. The majority of the coils rolled in North are supplied to the German or foreign works of the two partners Alcan and VAV. There they undergo subsequent processing, such as further rolling, even down to the thinnest foil, coil coating, painting or foil laminating, slitting to narrow strip or cutting to sheet. This material, on the other hand, will be used for a wide variety of end products. From packaging foil to tops for yogurt tubs, food packaging and beverage cans, to plates, meal dishes and containers. For offset printing of picture books, advertising brochures, newspapers and other printed material. For caravan and truck bodies, radiators and seat frames, as inner panels, bodywork parts and wheel rims. Alunorf has the feedstock to match every product. All production areas, remelt, hot mill and cold mill, are geared to the highest possible competitiveness and economy. Continuous development and improvement, together with well-trained staff, help to maintain the company's leading position and provide job security in the plant. Cooperation with the partner companies has proved itself and prepared Alunorf in the best possible way for the challenges of changing and expanding markets, now and in the future.